actually 30% faster for Vega OS compared to Android is pretty impressive. But we're not going to talk about Vega OS or Amazon today. We're going to talk about testing. This is not a coincidence I'm wearing this t-shirt. So are you testing your code in React Native? Really? Yeah, okay. Some of you do, and you know that it's, or you probably know that it's a compromise. You either go with JavaScript-based tests with Jest, or you go with end-to-end tests with Maestro or Appium or something else maybe, but these are like pretty good. And you can either test this JavaScript in some kind of isolation, specifically isolation from your native side of the code, or you can test everything end to end, but then you need to, learn a lot of new things, and we don't like learning new things usually as developers. I mean, we say we do, but reality is slightly different because learning hurts, but it's really good for you. So with the JavaScript test that we run with Jest, let's go through some of the trade-offs. There are some good sides. We can do TDD with JavaScript. Because we have lightning fast execution. They're running all the time. You have watch mode, a lot of cool stuff, and you can do it with Jest. You can do it with VTest. It doesn't really matter. It's the same great developer experience. And what's most important as JavaScript developers, you can test your JavaScript code with JavaScript, which is so much easier. But there is a downside to it. We run our tests in the Node.js. I'm not sure if you're all aware, but this is what happens. In React, when you're testing your React apps or your React Native apps, you're not actually rendering in your browser or in your native app, because there's no browser, no native app. There's just console and Node.js, and it's not a real device. So we're mocking a lot of stuff and basically assuming that everything is working there. And with end-to-end testing, it's a bit better because we can run our tests on real devices. We have actual user experience, and we can test that, and we can test full user flows. On the downside, these are usually a little slow to run, also slow to start because they require a build step, and there is some flakiness involved in doing that because of the sheer complexity. We need to run databases, we need to handle JavaScript native stuff. A lot of things can go wrong, and they often do. So we ended up in this status quo where we have those JavaScript-based tests, which we use them for unit or integration testing, component tests, CDD, and they written by us, developers. And we have end-to-end tests, which are testing full user flows. They're usually run once a day because they're very expensive. I know code bases where tests were running for 17 hours straight. And they usually run on CI because they're too slow and cumbersome to run locally. What's most important, they're written by QA engineers, and JavaScript developers, usually not QA engineers usually not JavaScript developers, because they're good at different things. JavaScript developers are building stuff, QAs are destroying your stuff. And they're very good at it. The better they are at it, the better QA developers they are. So yeah, but this talk is about native modules, right? And not about unit or end-to-end testing. So I think I got carried away a little bit, and we're in a lightning talk. So tell me, have you ever written a native module for a React Native app? And it can be Expo module, Turbo module, native module, legacy, new architecture, Nitro module, of course. There's a lot of you. So have you written a test for it? Yeah. I'll not comment that. But this is expected. This is expected, and it's not your fault. This guy created like 50 or 100 native modules, and he created Nitro modules. Of course, this is Mark Rosavi, hero of React Native, and he can tell you, and I can tell you, that testing native modules is painful, and this is why you're not doing it, because it's hard. So what it involves today, it requires you to add new tools to your code base that you're not familiar with. You need to learn a new DSL, like usually they're YAML, or there is some custom TypeScript syntax, something that you would need to learn about best practices, shoot yourself in the foot a few times. And there's also this very weird thing when you need to actually build an example app that will like simulate actual UI that no one ever builds, because your users are building them themselves. That is only for simulating using your module. So this looks more or less like this, and this is like one of the simplest Maestro tests. It's very descriptive. It's very nice to read, and by humans. And yeah, here we can tap what is on the text input. We can input some value. Then we need to tap on a few buttons to save and read values from MMKV library in this example. And then we need to make sure that something happened on the screen and press OK, because we've shown this as an alert. So to do all of that, our example app needs to have a text input, 2 buttons, alert, and some logic to bind this all together. And of course, as a native React Native developer, you need to write it. So what happens is that JavaScript developers are using tools built for QA engineers, or hopefully AI agents in the currently in the near futures. And this is not really optimal, because it would be great to use tools that are designed to do one thing really well. And let me cite a really good quote from the React testing library documentation. It's their guiding principle that the more your tests resemble the way your software is used, the more confidence they can give you. And our software is used by developers. They're importing the library and they're calling some functions on it, and not directly by our app users. This is just a way we're working out the problem. So wouldn't it be great to test our native stuff in JavaScript? I think it will be great. So let me introduce you to Harness. Harness is a new testing library, or a helper library for testing frameworks. That is a missing middle ground in React Native modules testing. It's created by a friend of mine, Szymon Chmal, who is working at ColeStack Incubator, and he's doing a bunch of cool stuff like Harness or Rosanite or Voltra recently. So a example test look like this. This is a normal JavaScript test. We have describe, we have before, we have it, we have expectations. That's it. You already know it. And you already know how to run it, because it's just running and it runs like this. Running just. Harness is preparing some stuff for you. Under the hood, it runs Metro to bundle your JavaScript, and opens your app and closes multiple times depending on how many tests you have. It does some initialization and tear down logic to make sure that the test state doesn't leak between the runs. This is all you have to do. You already use these tools. You already use the syntax. So how to add Harness into your code base? We'll get to that. But what's important with Harness is that it allows you to test fully native code. You have access to all of that. There is no complex UI that you need to mock out, create. You can run it through Jest. You can write your test in JavaScript. Once again, the downside, it requires a build step because it interacts with native environment. So what Harness is doing for you is the bundling. So it integrates tightly with Metro. It integrates with Jest using a feature called custom Jest runners. And thanks to the custom Jest runner, it's able to feed the information from the native realm and put this back into our JavaScript environments and other scripts that are living in Node.js land. So how to add it in your code base? There's one new file necessary called RNLConf. You specify some entry points, runners for all the platforms, and inside you can say whether you want to run with Android emulator or iOS simulator or a real device. It's also supported. With Jest config, we just need to add the preset React Native Harness, and you can run it next to your regular unit test using the projects feature. I really encourage you to give it a try if you haven't. And for Metro, it's adding one more higher order component with RN Harness specifically, and you're done with the setup. So you already know how to write tests with Harness, because it's just the same way as you would run and write with Jest. So imports that are changing. You have the test API, you have lifecycle matcher, you have helpers for lifecycle, you have matchers, and you also have mocking if you like. And this is all powered by vtest helpers under the hood because they're isomorphic. They're pretty cool. So an example test for MMKV now can look like this. We don't need to create any artificial stuff. We just import the library, instantiate it, read the value, and assert the way we would normally do. And this is exactly how you would use MMKV in your application. In the future, we may experiment with testing actual UIs, but it's not the focus for now. I think Maestro is doing a really good job at it. So kudos to folks that have created and came up with the idea. Shimon, who I mentioned already, Mike, our founder, and Mark Rusavi, who was kind enough to help us validate this idea in his libraries, and who I think originally came up with a need for such a library. So thank you, React Native London. My name is Michał Pierzchała, principal engineer at Callstack. You can find me on X, not Twitter, or GitHub under the MyKey handle. And please scan this QR code, go to reactnativeharness.dev, give it a try. If you build a native module, you can, do it in 20 minutes or so. Thank you very much.